Okay, let's move on to the next concept, law of conservation of energy. So that means here we learned that the form of energy can be changed from one form to another. What happens to the total energy of a system during or after the process? Whenever energy gets transformed, the total energy remains unchanged. So this is the law of conservation of energy. According to this law, energy can only be converted from one form to another. It can neither be created nor be destroyed. The total energy before and after the transformation remains the same. The law of conservation of energy is valid in all situations and for all kinds of transformation. For example, let an object of mass be made to fall freely from a height h. Okay, it made to fall freely from height h at the start. So if the object is at a height this height, its mass is m, or it's to be at height h and it's falling down freely. Okay, so at initially its potential energy is mgh because object is at rest. So that if the rest object is at rest, it has a potential energy. Okay, so and kinetic energy is, now the kinetic energy is 0. Remember that if the object is at rest, it has a maximum potential energy, that is mgh, and kinetic energy is 0 because velocity of that object is 0 or speed of the object is 0. Now the total energy of the object is mgh. Okay, as it falls, its potential energy will change. If it falls now the object is in position, and after some time object in this position, after some time object in this position, so it is the ground. So this is, now object is in this position. Okay, when it falls down, its kinetic energy will changes and the its potential energy is changes and it will convert it to kinetic energy. Now the kinetic energy is of mv square. The object has a kinetic energy is of mv square. So here the potential energy is decreases and kinetic energy is increases. When object is reaches the ground, the height will 0 but kinetic energy is maximum. Okay, so now the total energy is what? Potential, the sum of potential energy and kinetic energy. So this always constant. Constant means remains same. Before and after the action, the potential energy and kinetic energy is constant, means it's same at all the time. Okay, this sum of kinetic and potential energy is called what? Mechanical energy. Remember that? Mechanical energy. Okay, the sum of kinetic energy and potential energy of an object is total mechanical energy, and before and after the action, the sum of both kinetic and potential energy should be constant. That means it should be same. The next one is rate of doing work. What is rate of doing work? It's nothing but power. The power means it is measure the speed of work done. That means work done is how fast or slow. It measures the how fast or slow work is done. So power is defined as rate of doing work. It is represented in equation by the work done divided by time. This is the work done by time and its unit is 1 watt. Its unit is 1 watt. Also this unit can be represented as 1 joule per second. That means here work done can be represented. Its unit is joule and time unit is second. So 1 joule per second. 1 joule per second. Okay. And one more thing here, that the power of an agent may be vary with the time. That means if the object power will vary with the time, so it's doing work at different rates at different intervals of time. That means agent may be doing work at different rates at different intervals of time. Therefore, the concept of average power is useful. So, the average power means dividing the total energy. Remember that average power. Average power means the object may be doing work at different intervals of time at different rates. The different rate can be represented by average power. So this is defined by total energy divided by total time. Remember this one. Okay, average power is total energy divided by total time. The last concept is commercial unit of energy. The unit joule is too small and hence it is convenient to express large quantities of energy. That means the unit of joule is very small, so it is inconvenient to express large quantities of energy. So because of that reason we use bigger unit of energy, that is kilowatt. Remember that, kilowatt. Okay, so 1 kilowatt can be written as 1 kilowatt is 1 kilowatt into 1 hour. Okay, so 1 kilo means 1000 watt into 3600 seconds. So multiply these two, we get so 360000. We can write it as 3.6 into 10 power 6 joule. So just shift the points. This is 3.6, 1, 2, 3, 4, 5, 6. It can be written as 10 power 6 joule. This is 1 kilowatt hour. You should remember that 1 kilowatt hour is equal to 3.6 into 10 power 6 joule. Okay, because here if the use to represents the energy, the unit is joule. It's a very small, so it is inconvenient to express the large quantities of energy. So we use bigger unit of the energy, that is kilowatt hour. If the 1 kilowatt hour is equal to 3.6 into 10 power 6 joule.